Hi, my name is Mosh Hamadani, and I'm going to be your instructor in this course. Let me quickly explain in 3 minutes what Angular is, what you can do with it, and what you're going to learn in this course. Angular is a leading framework for building JavaScript-heavy applications, and often it's used in building single-page apps or SPAs. What is a single-page app? Well, in a standard web application, when we click on a link, the entire page is reloaded. In a single-page app, instead of reloading the entire page, we replace the view that is in the content area with another view. We also keep track of history, so if the user navigates using back and forward buttons, we restore the application in the right state. As you might guess, these applications provide a very fast and fluid experience. Gmail is a very good example of a single-page application. So anytime you want to build an application that has a lot of JavaScript, like single-page applications, but not necessarily, you may want to look at Angular to build this application in a modular, maintainable, and testable way. Sure, there are lots of other frameworks out there that have the same promises, so why Angular? Well, Angular is one of the leading frameworks in this space. It's been around for quite a few years. It's just been rewritten with the best practices for the future. It has a huge community support. It's backed by Google. It's not going away anytime soon. And as Google Trends shows, the demand for Angular developers is increasing constantly. So in this course, I'll be teaching you Angular 2 from scratch in a step-by-step fashion. Whether you're familiar with Angular 1 or not doesn't really matter, because Angular 2 is an entirely new framework. And by the way, we'll be using TypeScript. Why not JavaScript? Well, TypeScript is a superset of JavaScript. Any valid JavaScript code is valid TypeScript, which means you don't have to learn a new programming language. TypeScript brings some useful features that are missing in the current version of JavaScript supported by most browsers. We get modules, classes, interfaces, access modifiers like public, private, IntelliSense, and compile time checking. So we can catch a lot of programming errors during compile time. If you have never worked with TypeScript, I can guarantee you're going to absolutely love it. Okay, now you probably want to say, Mosh, tell me what I'll be able to do by the end of watching this course. Well, it's easier to show you. By the end of watching this course, you're going to build a real-world application like this. So we have a list of users coming from a RESTful API with CRUD operations. We can add a new user. Here we have a form with custom validation and dirty tracking. So if I fill out 1 or 2 fields and accidentally try to navigate away, the application will warn me. We also have a list of posts. We have pagination, which is done on the client, and filtering, which is done on the server. We also have master detail. So as we click on a post, we can see its details loaded dynamically from the server. These are the patterns that you see in a lot of real-world applications. And in this course, you're going to learn how to implement these patterns with Angular 2. In a nutshell, we have 4 key players in an Angular 2 app: components, directives, routers, and services. Let's take a look at each of these building blocks in more detail. At the very core, we have components. A component encapsulates the template, data, and the behavior of a view. So it's more accurate to call it a view component. Every Angular 2 app has at least one component, which we call the root component. But in the real world, an application often consists of tens or hundreds of components. For example, imagine we want to build an application like Udemy. We can divide this page into 3 components: navigation bar, sidebar, and courses. So each component has the template or HTML markup for the view, as well as data and logic behind that view. Components can also contain other components. So in the list of courses, we can have multiple course components, and in each course component, we can have another component for rating that course. The benefit of this architectural style is that it will help us break up a large application with various complex views into smaller, more manageable components, or as I said, view components. Plus, we can reuse these components in different parts of an application, or even in a different application. For example, we can reuse this rating component here in a totally different application. Now you might be saying, look Mosh, I understand what you're saying about components, but what are these components really like in the code? A component is nothing but a plain TypeScript class. So just like classes in other programming languages, it can have properties and methods. These properties hold the data for the view, and the methods implement the behavior of the view, like what should happen when we click a button. Now, if you have never worked with Angular before, one thing that may be new to you is that these components are completely decoupled from the document object model, or DOM. In applications written with plain JavaScript or jQuery, we get a reference to a DOM element in order to modify it or handle its events. In Angular, we don't do that. Instead, we use binding. So in the view, we bind to the properties and methods of our component. If there is a change in the value of a property, the DOM element bound to this property will refresh automatically. So we can't and shouldn't get a reference to that DOM element in order to update it. Similarly, to handle an event raised from a DOM element like click, we bind that event to a method in our component. When the user clicks that element, the corresponding method in our component will be called. Now, in case you're curious why these components are decoupled from the DOM, the reason is that this makes our components unit testable. If we have a plain class that is nothing but a bunch of properties and methods, we can easily unit test it without having a document object model. Now, sometimes our components need to talk to backend APIs to get or save data. To have good separation of concerns in our applications, we delegate any logic that is not related to view to a service. So a service is just a plain class that encapsulates any non-user interface logic, like making HTTP calls, logging, business rules, and so on. We have another key player in Angular apps, and that's a router, which is purely responsible for navigation. So as the user navigates from one page to another, it will figure out based on changes in URL what component to present to the user. You will learn more about this in the section titled Building Single-Page Apps. And the last key player in Angular is a directive. Similar to components, we use directives to work with the DOM. But a directive, unlike a component, doesn't have the template or HTML markup for a view. We often use them to add behavior to existing DOM elements. For example, we can use a directive to make a text box automatically grow when it receives focus. Angular has a bunch of built-in directives for common tasks like adding or removing DOM elements, adding classes or styles to them, repeating them, but we can also create our own custom directives. So this is the big picture. As you go through this course, you will see each of these building blocks in action. Okay, let's jump in and set up our development environment. First, in case you don't have Node on your machine, download it from nodejs.org and install it on your machine. It's pretty easy and straightforward to install. With Node, we get a tool called npm or Node Package Manager, which we use for managing dependencies of our application. So once you install Node, open up Command Prompt on Windows or Terminal on Mac and type npm install -g TypeScript. If you're a Mac user, you need to put sudo in the front. With this, we install TypeScript globally on our machine. The next thing you need is a code editor that supports TypeScript. In this course, I'll be using VS Code, which is a beautiful, lightweight, and cross-platform editor from Microsoft. You can use Sublime, Atom, IntelliJ, Visual Studio, and any other editors that supports TypeScript. And finally, I'll be using Chrome as my browser. You can use any browsers, but I would highly recommend to use Chrome because we'll be working with Chrome developer tools throughout the course, and I want to make sure you have the exact same experience as me during the videos. The proper way to create an Angular app is to use Angular Command Line Interface, or CLI. But this tool is not ready yet. So for the time being, I've created a seed project that I've put together based on the guidelines on the Angular website. We'll be using this seed project throughout the course. So download the attached zip file and put it somewhere on your machine. Now, let me show you what you will find inside this zip file. So this is VS Code editor that I'll be using throughout the course. Look, inside this folder, you will find a few configuration files, an index.html, and an app folder, which is the container for our application. Inside this app folder, we got a couple of TypeScript files. One is boot, which is the main or starting module of our application, and the other is app.component.ts, which is the root component of our application. We'll look at these files in more details in the next section. This tsconfig.json is the configuration file for TypeScript compiler. So it uses this configuration to determine how to compile, or more accurately, transpile our TypeScript files into JavaScript. For example, you can see that the target JavaScript is ES5, which is the current version of JavaScript. If you want to understand any of these settings in more detail, it's best to look at tsconfig documentation on GitHub. Typings.json is another configuration file for TypeScript. When using external JavaScript libraries in TypeScript, we need to import what we call a TypeScript definition file. This type definition file gives us static type checking and IntelliSense for that JavaScript library. And this is where we reference that TypeScript definition file. You'll learn more about this later in the course. Now, this package.json is a standard Node package configuration. So here you see the name of our application and its version. Under scripts, we got a few custom Node commands, which we'll look at shortly. Then we got the dependencies for our application. So we can see we've got dependency to Angular 2, System.js, and so on. I'm going to move on because I would like to fast track to running our first Angular app. But if you're the kind of developer who prefers to understand the details first, I've attached a PDF with the details of these dependencies. Okay, now we need to install these dependencies. So open up Command Prompt on Windows or Terminal on Mac and go to the folder where you extracted the zip file. And then run npm install. npm will look at our package.json file and download our dependencies from npm registry. Just be aware that this is going to take several minutes for the first time, so be patient. Once these dependencies are installed, you will see a new folder here called Node Modules. So all our dependencies and their dependencies will be stored here. Now let's have one more look at package.json. Look under the script section. Here we have a few custom Node commands. The one we'll be using a lot is start, which is the shortcut for concurrently running two commands: running TypeScript compiler in the watch mode and starting our light web server. With TypeScript compiler running in the watch mode, we can modify and save a TypeScript file, and then the TypeScript compiler will automatically generate a JavaScript and JavaScript map file in the same folder. This JavaScript file is eventually the one that will be loaded in the browser, but we never have to view or modify it. We code purely in TypeScript. So back in the terminal, type npm start. So now our TypeScript compiler is running in the watch mode and our light web server is started. This also launches our default browser, which on my machine is Safari. So I have to manually open up Chrome and navigate to localhost port 3000. And this is our first Angular app up and running. Okay, now let me show you something. Look at this app folder. Next to each TypeScript file, we have two files that are generated by TypeScript compiler. One is a JavaScript file, and the other is a JavaScript map file, which is used during debugging. So if something goes wrong and we try to debug in the browser, this map file will take us to the corresponding line in our TypeScript file. Now let's open up this app.component.ts and make a small change. So I'm going to explain this very briefly, but in the next section, we'll have a closer look at this syntax and you will create a component from scratch so you will know exactly how everything works. So basically, our root component is nothing but a plain TypeScript class. It's just decorated with this component decorator. This decorator or annotation adds metadata about this class. So all the building blocks of Angular 2 apps that I talked about are essentially plain TypeScript classes that are decorated with some decorator. So here in the template, we have a heading. Let's change this to Hello Angular. Now, before saving the changes, let me bring up my terminal here. Notice that when I save changes, because TypeScript compiler is running in the watch mode, it will detect that this file is changed and it will regenerate the corresponding JavaScript and JavaScript map files. Then I'm going to switch back to Chrome and you will see that it will get refreshed automatically. So we don't have to press F5 to refresh the page every time our application code changes. This is Browser Sync, which is a node module that our Lite web server uses. Okay, now I'm going to go ahead and save the file. Look at the terminal. TypeScript compiler regenerated our JavaScript file. Now let's switch over to Chrome. So Chrome automatically refreshed. So this is going to be our development experience throughout this course. We write TypeScript code and TypeScript compiler automatically generates JavaScript files for us. It's simple and easy, but if you want to build a production application, you may want to include TypeScript compilation as part of your build process. So if you're using a build automation tool like Gulp or Grunt, TypeScript compilation would be another step in your build process. That's beyond the scope of this course, or at least we shouldn't worry about these complexities at this point and just focus on building Angular 2 apps. Just be aware that with this workflow, sometimes it may take a couple of seconds until TypeScript compiler detects your changes. Also, I've noticed that this Lite web server has a bug and sometimes it terminates unexpectedly. So if you're not seeing your changes, have a look at the terminal and see if Lite server has terminated. If so, just terminate the session with Ctrl and C and then run npm start again. Okay, let me quickly give you a heads up about what you're going to see over the upcoming sections. In the next section titled Angular 2 Jumpstart, we're going to create a component, a service, and a directive from scratch. So by the end of the next section, you will have an idea of what it is like to build an Angular 2 app. You will see the big picture in the code. From that point, in every section, we'll explore one concept at a time. You'll learn about property and event binding, building reusable components, controlling rendering of HTML, building forms, using reactive extensions and observables, calling backend services, building single-page apps, and finally, over the last two sections, you'll put everything together and build a real-world application. Just to let you know, in this course, I'm not going to touch on Angular 1 and how it's different from Angular 2, and there is a reason for that. Not every student taking this course is familiar with Angular 1. So I don't want to distract this group of people with the old way of doing things, which has no place in the future. If you have an application written in Angular 1, your best source for upgrading that is Angular website. They have fully documented the process and various strategies. You can run Angular 1 and 2 side by side and upgrade one module at a time. With all that, let's get started for the next section. Well, hello, my name is Mosh. Thanks for watching my YouTube channel. This video you've been watching so far is actually part of my Angular course on Udemy. If you're interested to have the complete 6.5-hour course, you can get it with a discount using the link in the video description. And if not, that's perfectly fine. Continue watching as the second section is coming up. I hope you enjoy and have a great day. So in the introductory section, you learned about the core building blocks of Angular 2 apps: components, directives, services, and routers. In this section, we'll implement a component, a directive, and a service from scratch. So by the end of this section, you'll have an idea of what it is like to build an Angular 2 app. We'll look at routers later in the section called Building Single-Page Applications. So let's get started. All right, so I've got the project open in VS Code. I've also got the terminal running here. So our lightweight web server is in the background.
Plus, our TypeScript compiler is into watch mode, is looking for changes. And when it observes a change in a file, it will transpile it into JavaScript. And then the browser sync will kick in and automatically refresh the browser. You're going to see this in a second. So back to VS Code. In Angular 2, each of the building blocks I talked about, like components, directives, and routers, are plain TypeScript classes. And that's one thing that I love about Angular 2. The API is much simpler and cleaner. So I'm going to start by creating a class. So right-click, App, New File. I'm going to call it courses.component.ts. Note the naming convention. So we start with the name of the component, like courses, then .component, then .ts. Okay, so to create a class, we start by export class courses component. What is this export here? In TypeScript, each file is considered a module. In each module, we often export one or more things, like a class, a function, or a variable. In this case, I'm exporting courses component class, so it will be available to other modules in my application. Later, when I need this class, I can import it, as you will see shortly. All right, so we have a class. Now, how does Angular know that this class is going to be a component? It looks for specific attributes or metadata on your classes. For example, to make this a component, we need to apply the component decorator to this class. A decorator in TypeScript is like an attribute in C# or an annotation in Java. Many other languages have similar concepts. So first, I need to import the component decorator from the core Angular module. Import, curly braces, component, from, here's a string that specifies the name of the module, Angular2/core. So in Angular2/core module, we have a decorator called component. And here I'm importing it. So if you look at the source code for that module, you will see that they have exported this component there, so we can import it here. That's the idea. Now these decorators are functions, so we need to call them. @ component. All decorators need to be prefixed with an @. I know this is a function, we just call it like this. Look at the IntelliSense. It's telling me that this function takes an object. So here's my object. And you can see the list of attributes that we can add in this object. In this video, we're going to look at two basic attributes. One is selector, which is a string, as you can see in the IntelliSense. I'm going to call it courses. So this selector field here specifies a CSS selector for a host HTML element. When Angular sees an element that matches this CSS selector, it will create an instance of our component in the host element. So here I'm assuming the host element is an element with the tag courses. The next attribute is template. And this template specifies the HTML that will be inserted into the DOM when the components view is rendered. We can either write the template here inline or put it in a separate file. I'll get to that later in the section about components. So let's just display something very simple. Courses. So that's all. We have built our first component. As easy as that. Now we need to add this courses element here somewhere. So first save this file and then go to app.component.ts. If you're using VS Code or Sublime Text, you can press Ctrl P on Windows or Command and P on Mac. And here you can type the name of the file in your project. So app.component.ts. If you're using a different editor and you don't have this shortcut, just go to the app folder and you will see app.component.ts there. All right, look at this component. It looks familiar, doesn't it? So first we're importing the component decorator from Angular. Here we're calling it, so it's a function that takes an object. And this object we have two fields, selector and a template, just like our other component. And finally, we've got export class app component. So this app component is the root of your application. It's a view component that takes control of the entire app or the entire page. And here's a template for this view component. I'm going to change this and add courses element here. Now, if I run the application now, you're not going to see the courses component. Why? Because Angular sees this courses tag, but it doesn't know which component is responsible for that. Even though we defined a component in our application, nowhere we have referenced it. So Angular does not scan all your files to discover your components. It will only recognize the components that you have explicitly referenced. So here we need to add a reference to courses component so it can be discovered by Angular. So we supply a new field here called directives, which is an array. Inside this array, we specify any directives or components we have used inside the template for this component. Just to refresh your memory, we use directives to extend or control document object model. We can define custom attributes or custom elements that are not part of standard HTML. In this case, we used our courses component to define a new element. So every component is technically a directive. The difference is that a component has a template and a directive doesn't. So back to app, we need to reference our component here. Courses component. Now look at the red underline. Cannot find name courses component. And that's what I love about TypeScript. Compile time checking. So we need to import this courses component. Import, curly braces, courses component from, what is the name of our module? For the custom modules that we define, we need to specify their path in the file system. So this file app.component.ts is in the folder app. Look, app folder, and here's app.component.ts. And here's our courses component. So they're both in the same folder. So back in app.component.ts, here I type /, which means start searching from the current folder. And then the name of the module. So courses.component without TS extension. Save. Now let's look at our terminal. Okay, TypeScript compiler detected a change. So it transpiled our TS files into JavaScript files. And now if you go to Chrome, look, our courses component is successfully rendered on the page. Let's inspect the elements. So in the HTML, we have this my-app element, which is the host element for our app component. Let's have another look at our app component. Look, the selector is my-app. So when Angular sees my-app, it's going to put this template there, and h1 with the courses element. So back in Chrome, inside my-app, you see h1 and courses. And courses is the host element for our courses component. And inside that, you see h2. But where is this root my-app defined? It's in our HTML. So back in VS Code, open the project folder, collapse app, open index.html, scroll down. In the body, we have referenced my-app. So Angular saw this and it rendered app component. As I explained, a component encapsulates the data and the logic behind a view. So we can define properties here in our component and display them in the template. Let's define a simple string property called title. So title, string, and let's initialize it here. So you see, in TypeScript, unlike JavaScript, we can set the type of our variables. Now, in this particular example, we don't necessarily have to set the type because it can be inferred from the value assigned to the type. So I can remove :string, directly initialize it. And now if I hover my mouse over title, the IntelliSense shows that this property is a string. Okay, now let's change the template and display the title. First, I'm going to change this single quote to backtick, which will allow me to break up this template into multiple lines. The backtick character is on the top left of your keyboard just before the number 1. There you go. And change the other one. Now break it up. And to render the title, we use double curly braces. This is called interpolation. Now, if the value of this property in the component changes, the view will be automatically refreshed. Angular will take care of that, so we don't have to do anything special. And this is called one-way binding. We also have two-way binding, which is used in forms. For example, when you type something into an input field that is bound to a property, as you modify the value of the input field, the property will be updated automatically. You will see that later in the course. So save, back to Chrome. It takes a couple of seconds until TypeScript compiler detects the changes, regenerates the files, and look, browser sync updated the page automatically. And here's the title. Now let's take this example to the next level. I want to display a list of courses. So first, I would declare a property in the component, courses, and initialize it to a string array. Course 1, course 2, and 3. And then in the view, I'm going to use a UL and a bunch of LIs to render the courses. Like this. Now, I want these LIs to be repeated for each course. So we can use a special attribute here called ng_for. And note the asterisk. This is part of the syntax, and later I will explain why. We set this to an expression. Something similar to the expressions we write in for each loops. Hash course of courses. What does this mean? Courses is the object we are iterating, which is in this case the property in our component. Of is just a keyword, and hash course is a way to declare a local variable in our template. So similar to for each loops, this is our local variable that in every iteration it will hold one course at a time. Now, between li tags, again we can use double curly braces or interpolation to display this course variable here. Save, back to Chrome. There you go. So you see templates in Angular look like HTML most of the time. But sometimes we use special attributes like ng_for here, which is an example of a directive. So this directive extends the HTML and adds extra behavior. In this case, it will repeat the li element based on the expression assigned to it. At this point, our component is rendering a hard-coded list of courses. But in a real-world application, we often get the data from the server. As I explained before, this component should not include any logic other than the view logic. So I'm not going to write the code to call the server and get the list of courses. Any logic that is not about this view should be encapsulated in a separate class, which we call a service. So let's create a service that this component will use to get the courses from the server. So in the app folder, right-click, new file, course.service.ts. Note the naming convention. We start with the name of the service, in this case course, then .service as a suffix, and then .ts. A service is just a plain class, nothing more. So export class course service. I'm going to define a method here, get courses. I can explicitly set the return type here, like string array. But now the compiler is complaining because a function whose declared type is neither void or any must return a value or consist of a single throw statement. Basically, the compiler is complaining because the return type is a string array, but we have not returned anything. So I'm going to go back to our component, Control P on Windows or Command P on Mac, courses.component.ts. I'm going to get this array of courses, cut, and back in the service, paste it here, and return it. For now, we don't want to get distracted by details of consuming a RESTful API. So let's just imagine this service will actually call the server to get the data. For simplicity, for now, we just return an array. All I want you to pay attention to is that the component is not going to have any code to get the data from the server. It will simply delegate to this service, as you will see soon. So we created this service. Now we need to use it in our component. So course.component.ts. First, we need to import the service. So on the top, import course service from /, which means start from the current directory, course.service, that's it. No .ts here. Now that we have imported this symbol, we need a reference to the service. One way to do it is to create it in the constructor of courses component. So I can create a constructor here, constructor, and new up course service, like this. But this would cause tight coupling between courses component and course service. And this will lead to two big issues. The first issue is that, let's say in the future, we create a custom constructor for our service that takes 1 or 2 parameters. Then we would have to get back to this component and any other components in the application that is using the service and modify its instantiation. So add the extra parameters here. So this is very fragile. It will cause a lot of cascading changes. A more serious problem of this tight coupling is that we won't be able to isolate this component and unit test it. Because when unit testing this component, we don't want to have a server up and running with a RESTful API. We want to use a fake or a mock service that doesn't really need a server. And this way we can isolate the component and unit test it. So to solve this issue, we should not use the new operator here. Delete. Instead, we pass a parameter here. Course service, which is of type course service. Now note the naming convention. The parameter name here uses camel case, so the first letter of the first word is lowercase, and the first letter of every word after that is uppercase. But the naming convention for our class uses Pascal case, so the first letter of every word should be uppercase. So with this change, our component is no longer tightly coupled to the service. When unit testing this, I can simply create a mock or a fake service and pass it in the constructor. It wouldn't care. Now you might ask, but somewhere we need to create the service and pass it to this component. So how is this going to happen? That's when a dependency injection framework comes into the picture. The job of dependency injection framework is to inject dependencies of your classes when creating them. So when creating a course component, it looks at the constructor and sees we need a course service here. This is a dependency. So first it will create an instance of this service and then inject it into the constructor of this class. This is what we call dependency injection. But how do we get a dependency injection framework? Well, Angular already has that built into it, so we don't have to do anything magical. There is just one more tiny step we need to do here, but I'm not going to do it yet. I'm going to run the application now, so you can see a very important error, and then we'll come back and fix it. So save, back to Chrome. Okay, right-click somewhere, inspect. You see we have 3 errors here. In the console tab, scroll up. Look at this error. No provider for course service. So from courses component to course service. This is the kind of error that you may often encounter when building Angular 2 apps. And this simply means courses component has a dependency on course service, but Angular does not know how to create that service. So we need to teach it. So back in the code, in our component metadata here, I'm going to add a new field. So after the template, providers. Look at the IntelliSense. Its type is any array. Any in TypeScript is a type that can hold any objects. It's like var. So we pass an array here. In this array, we specify the dependencies for this component. In this case, course service. And this will solve our problem. Now let's finish the initialization of the courses property. So in the constructor, this .courses equals course service dot, look at the IntelliSense, get courses. Now our component is not coupled to the service. It doesn't care where the data is coming from. We have good separation of concerns. In the service, we may get the data from a RESTful API on the server, or we may get it from local storage in the browser, or from a cache, or we might have hard-coded in an array. The component doesn't care. Now I've got a small exercise for you. I want you to use what you learned in the past few videos and extend this application to something like this. So below the courses, I want you to display the list of authors. Just to give you a bit of direction, start with a component. Then set the required properties in your component and use interpolation to render them like this. Then extract the part that is supposed to get the list of authors from the server and put it in a service. And finally, use dependency injection. And please, please, please spend 10 minutes and do this exercise. Because later, we'll get into more complex topics, and I want to make sure you master the fundamentals before we get there. So please do your exercise, and if you get stuck, that's perfectly fine. In the next video, I will show you my code. Okay, so first I started by creating authors.component.ts. In this module, first we import component decorator from Angular. Then we import author service. Next, we apply the component decorator on our authors component class. The selector I have used for this component is authors. So anywhere in the HTML where we have authors element, this component is going to be rendered. And here's the template. This is pretty much identical to what we did in the previous video, so I didn't want you to do anything additional. I just wanted you to get used to this new syntax. That's all. Also, note the providers field here. Because we're using dependency injection to inject author service into this component, we need to teach Angular how to create an author service. And we do that by using the providers field here. In this component, I have two properties. Authors, which is an array of string, and title, which is just a simple string. In the constructor, we get author service, and then use that to set the authors property. And then in app.component.ts, I modified the template here. So I added authors element just below courses. So you see with these components, we can break up a big page with lots of different features into smaller, more manageable, more maintainable components. Plus in the future, I can get these authors and put it on a separate page instead of putting below courses. And we'll get there very soon. Now, when I did all this, I ran the application, but I did not see the authors. I didn't have any errors, so I was wondering, why is it not rendered? Then I came back here and I realized I've added this authors element here, but Angular doesn't know which component is responsible for that, because I forgot to put authors component in the list of directives that this template is using. So chances are you made the same mistake as me. If so, this is your solution. All right, now let me show you a real-world example of a custom directive. Look at this text box here. When I click it, it expands, and when it goes out of focus, it shrinks. You probably have seen this in a lot of websites. Of course, the real-world examples are a bit more fancy. They have an animation. For now, we don't have to worry about this stuff. So in HTML, we use the input tag to render a text box. Now, I want to use a directive to extend the input tag such that if it has the attribute autogrow, it will have this behavior. So in VS Code, under app folder, I'm going to create a new file. Call it auto-grow, then .directive.ts. First, we start with a class, just like before. Export class, autogrow, directive. We need to decorate this class with the directive decorator. So first, we import it. Import directive from Angular 2/core. And then apply it here. In the metadata, I'm going to use two fields. One is selector, which you're familiar with from the components. So this is going to be a CSS selector for the host element. So when Angular is scanning a template, if it finds an element that matches this CSS selector, it's going to apply this directive on that element. I'm going to use square brackets to refer to an attribute. So if an element, like an input, has the attribute autogrow, this directive is going to be applied on that element. Next, I'm going to use host, which takes an object. And we use host to subscribe to events raised from this element. So I want to subscribe to two events, focus and blur. Note the syntax. Here we supply events and their handlers using key value pairs. So string, in parentheses, the event name, like focus, and then we set the value on focus. So this is going to be a method in our directive class. And this parenthesis here means we are binding this onFocus method to the focus event. One more time, parenthesis, blur, onBlur, parenthesis. Let's go ahead and create this method. Now here, we need to access the host element. How do we do that? We need to import two services from Angular. So on the top, I'm going to import element ref, which gives us access to the host element, and renderer, which is a service that we use to modify that element. Now we need to create a constructor for this directive. We give it two arguments. One is L, just an arbitrary name, which is of type element reference. The second is render, which is of type render. So Angular would automatically inject instances of element ref and renderer into this class. Dependency injection, right? Now we need these L and renderer objects in onFocus and onBlur methods. One way is to declare two private fields in this class and initialize them in this constructor using these arguments here. something like this. Let's call one of them underline L. So we use underline to indicate that this is a private field, which is of type element reference. And then we can type this, that underline L equals L. But there is a shorter and cleaner way to achieve the same thing. We don't need any of this stuff here. We can use the private keyword before the argument name, and the TypeScript compiler would automatically create a field called L in this class, and then initialize it with this argument. So I'm going to do the same here. That's it. Now we go to onFocus. We use this dot render dot set element style. You don't have to memorize any of this stuff. I just want you to see a directive in action. Later, we have a complete section on directives, so don't worry if all of this looks new to you. Now, the first argument is the element we want to apply a style on. So this, that L. The second argument is the name of the style, width. And the third is the value. Let's make it 200 pixels. Of course, this is just arbitrary. It's a very basic implementation. Ideally, we want to calculate that based on the content of the input. For now, let's not worry about it. And then I'm going to copy this line and put it here. So when it goes out of focus, I want to set it to, let's say 120. Again, this is arbitrary. Save. So this is all we have to do to implement a directive. So as you see, a directive is just a class that has the directive decorator. We give it a selector and then implement the logic inside this class. Now let's go to courses.components.ts. In the template here, just above the list of courses, I want to add an input. Input of type text, and apply AutoGrow attribute on it. Now, if you run the application, Angular is going to ignore this because it doesn't know what is AutoGrow. So we need to teach it to apply the AutoGrow directive whenever it sees this selector. So we use the directive field here in our component metadata, directives. We choose an array, and here we pass AutoGrow directive. Of course, it's not recognized because we haven't imported it yet. So on the top, import AutoGrow directive from auto-grow.directive. Now there is a temporary issue on my machine here, and that's why you see this red underline. Don't worry about it. Everything is going to work now. So in this section, we had a brief look at components, directives, services, and dependency injection. Throughout the rest of the course, you will learn more about these building blocks. In the next section, I'm going to show you how to use property and event binding to display data and handle events raised from DOM elements. So I will see you in the next section. So I guess you've been enjoying this video so far. Otherwise, you wouldn't watch all these 50 minutes. So I highly recommend you to take my complete Angular course because there are lots of things I'm going to teach you there. What you have seen so far is just the beginning. It was just an introduction. So as I told you before, you can get this course with a discount using the link in the video description. I hope to see you in the course.